In question 4 of this exercise, the problem statement is as follows. The students of a class are made to stand in rows. If 3 students are extra in a row, there would be 1 row less. If 3 students are less in a row, there would be 2 rows more. Find the number of students in the class. So we don't know the number of students. We don't know the number of rows or the number of students per row. What we know is that if the number of students per row is changed by a certain amount, for example, if it's increased by 3, then the number of rows decreases by 1. And if the number of students per row is decreased by 3, then the number of rows increases by 2. So how do we solve this problem? How do we find out the number of students in the class? Well, it would be very helpful if we have a visual to tell us what's really going on in this given situation. So I've drawn a visual for you. Just observe it carefully. So what I've assumed is just look at this grid first on the left. So I've assumed that there are S students per row in the original arrangement. There are S students per row and there are R number of rows. So the total number of students is, let's denote that by N. So the total number of students is S into R. Now the first part of the problem statement says if 3 students are extra in a row, there would be 1 row less. So if 3 students are added, so now look at this arrangement. So if 3 students are increased, so these red dots represent the 3 extra students per row. So the new number of students per row becomes S plus 3. But the number of rows reduces by 1. So the number of rows is now R minus 1. Okay, but what remains the same is the total number of students. So the total number of students is still equal to the product of the number of rows into the number of students per row. So the total number of students can be written as S plus 3 times R minus 1. So equating this expression with this expression will give us our first equation in S and R. So let's do that. So SR, this number, this original value of N, should be equal to S plus 3 times R minus 1. So let's expand it and see what we get. So SR is equal to SR, then S times minus 1, so that's minus S, then R times 3 or 3 times R, so that's 3R, and then 3 times minus 1, which is minus 3. So here the SR terms cancel out and we are left with a linear equation in S and R, and that linear equation is minus S plus 3R minus 3 is equal to 0. So let's call this equation 1. Now the second piece of information says if 3 students are less in a row, then there would be 2 rows more. So now look at this second reconfiguration. So the number of students per row has reduced. It has reduced by 3. So the new number of students per row is now S minus 3. But this causes the number of rows to increase. So you can see that there are 2 more rows that have been added, which means that the new number of rows is now R plus 2. Okay. But what still does not change is the total number of students. So I can write the total number of students as the product of SR plus 2 and S minus 3. So N is equal to S minus 3 times R plus 2. And now if I equate this original expression for N with this expression for N, I will get another equation in S and R. So let's do that. So SR should be equal to S minus 3 times R plus 2. So let's expand this, the RHS. So we get SR and then S times 2. So that's 2S. Then minus 3 times R. So minus 3R. And then minus 3 times 2. That's minus 6. And once again the SR terms cancel out and we are left with a linear equation in S and R. And that linear equation is 2S minus 3R minus 6 is equal to 0. So let's call this equation 2. Now we have a pair of linear equations in S and R, this equation and this equation. And we see that the coefficient of R in the first equation is 3 and in the second equation is minus 3. So let's simply add the two equations and that will eliminate R. and what we will get is, on the LHS we will get 2s plus minus s, so that's s, and the r terms will cancel out, and minus 6 and minus 3 is minus 9, so s minus 9 is equal to 0, which means that s is equal to 9. And now substituting this value of s into any of the two equations, let's say the first equation, I will get minus s or minus 9 plus 3r minus 3 is equal to 0, or 3r is equal to 12, or r is equal to 4. So I will get r is equal to 4. So in the original configuration there are s or 9 students per row, and there are 4 rows. So the total number of students is n is equal to s into r, or 36. So the answer is 36. But let's verify if this aligns with what is told to us in the problem statement. So if the number of students per row increases by 3, so the new number of students per row becomes 12, and the number of rows reduces by 1, so that becomes 3. So 12 times 3 is still 36. So this makes sense. And now if the number of students per row decreases by 3, so it becomes 6 instead of 9. And in this case the number of rows increases by 2, so the number of rows becomes 6. And now the total number of students is still 6 times 6, or 36. So even this makes sense. So our answer is correct. The total number of students is 36. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.